Okay, hey guys, I'm back again, and this time I thought I'd try something different. This time to avoid looking like an idiot, which I'm sure I've done in some past videos by saying something that's wrong. I wrote a script, and by wrote, I literally mean I wrote one on paper. So I might go to my website, quicknuclearscience.webs.com, and I'll take a picture and I'll put it on the files page. Um, so you can actually see this physical script I wrote. But anyway, now to the science. So, as you can already tell, this video will be about one of the hottest topics in physics today, the Higgs boson. So, first, before I start, I gotta say what it does if it exists. So, it gives particles mass. Now, most people think, like, I don't know, unless you're a particle physicist or a theoretical physicist or what have you, you probably think that mass is just sort of my squeaky chair. Anyway, you think it's just sort of an inherited part of having, that a particle has, right? You think it's just inherited. But that's not possible, though, because the photon has no mass, and then the W and Z boson have really they're really massive. They have massive masses. Great pun, huh? Anyway, they're some of the most massive particles we know, and the Higgs can solve that problem, and it can be described as a movie star, basically, at a party. So there's a party, and everybody's sort of even out, just like all the particles in space, even though they're not really even, but I'll just say something. And then the movie star comes in, everybody crowds over the movie star, and as the movie star moves around, it gets people are crowded around it, and this is like an indication of mass. And then once people are crowded around, they just sort of going what they're doing. So that's sort of how the Higgs mechanism can be described. And the Higgs mechanism was first proposed by Peter Higgs in the 1960s. But so now I'm talking about the search of the Higgs. This is one of the hottest topics. I said this is something that the media loves. They call Higgs the God particle, even though physicists don't like that and scientists in general, because it's not really true that Higgs isn't so important, even though it is important. So I think they committee decided it would be called the champagne bottle boson, I think, which is a really cool name. Anyway, so it's the only particle in the standard model that has been yet to be confirmed, like all the other particles in the standard model have. Yet it's necessary because the large mass of the W and Z bosons give inconsistencies in the standard model, and it's such a hot topic because in the one, it's the only thing in the standard model that hasn't been proven yet, and two, the standard model is okay if it exists. And also, if it doesn't exist, other forces can be necessary. Also, it's been going on for a really long time. More than 10 years they've been actively searching for it, and I'm sure they wanted to find it back when the Higgs mechanism was first proposed in the 1960s by Peter Higgs. Anyway, some scientists say there will even be more than one boson, sorry, not boson, particle. I'm sure they would be bosons also, but some say it could have shed light on some strong interactions that aren't very well understood by physicists at the moment. Others say that it could reveal super-symmetry. Sorry, it's kind of weird talking about a script that I wrote. I don't have the best handwriting, although yeah, that's why I have computers. Although, so yeah. So anyway, so in simple talk, sort of, the supersymmetry is sort of when there is it relates fermions to bosons, almost like antimatter and matter, in the fact that a fermion has a certain mass and certain quantum numbers about it, and then for that fermion there would also be a boson with the same mass and the same quantum numbers. So that's sort of the supersymmetry in simple talk. And supersymmetry, if the Higgs exists, supersymmetry might be in effect because, or might have been revealed and sort of up out there for judgment if because there are quantum corrections in the standard model would be canceled out by the super partners of the particles in the standard model. And so the search for the Higgs boson, if they don't find it, then that could be one of the answers, although that's not the only answer. There's many more. You can look it up online if you want to. So this search for the Higgs boson, it's been mainly going on at the main sites, although there's many other places. The Large Electron Positron Collider in Geneva, which currently houses the LHC, Tevatron and Fermilab in Illinois, and the LHC, which is the one that the media loves to talk about now. They're saying, oh, it's going to create black holes, destroy the world. It won't. But anyways, that's the one I love to talk about, and it's the one that's really, like, it's really thrown out there by the media a lot. And also, for a bit of a good reason, is that it can gather lots of data really fast, so it will discover the Higgs a lot faster than something like the Electron-Positron Collider did. But even if they produce a Higgs in one of these detectors, and if it exists, they've certainly already produced a Higgs in the detectors, even if they don't know it, or maybe they do. I don't know. They haven't released it in a press release maybe yet. But even if they saw it, it would last for such a short amount of time that they couldn't detect it in their detectors. They have to look for what it actually decays into, which would last for a longer time than the actual Higgs itself. And so it could be produced. So one of the ways it could be produced in the detectors, if you're wondering, among a couple of others, as shown in this article, right here, these two diagrams at the left, is that I'm referring to this one here. Two quarks could emit a W and a Z boson, which could hit together and form a neutral Higgs. Another way is that they two gluons could decay in the top and an anti-top quark pair, which could then form two combined again a neutral Higgs boson. So I'm sure there's other ways that's also possible for it to be created. But another interesting about the Higgs, this particle is all crazy, is that it's its own antimatter particle. I really don't know how that's possible. Nothing I can find really sheds any light on that. So if you happen to be working at the LHC and watching my videos, which if you are, that is really awesome for me, because that's kind of like my dream job, you know. All particle physicists, they want to work at the Large Hadron Collider because it's super duper fly. Yeah, referring to the Large Hadron rap again. I have the whole thing memorized. It's really great for annoying people, actually. But I love it, so not to diss it or anything. Great rap. And pretty correct, too, actually. But the closest we've actually gotten to finding the Higgs boson is at the Electron-Positron Collider, with which a 95% confidence level excluded it being set the lower boundary at 114.4 giga-electron volts for its mass of the Higgs boson. And then also in the same search, some events could have been the Higgs, but there were too few of them, and they didn't have enough certainty that they could say that the Higgs existed or not. But it's just something to add to the puzzle. So right now, where we are, as you can see, status as of March 2011. It's May, but close enough. You can see that the lower bound is at 114.4 giga-electron volts. And then they've said it can't be between 156 giga-electron volts of mass and 183 giga-electron volts, and that is with a 90% confidence level. And the lower bound of 114.4 giga-electron volts is with a 95% confidence level. And then indirect measurements here, it says that the 185 giga-electron volts and above have been excluded with a 95% confidence level by indirect measurements. And so Tevatron has played its part. The Large Electron-Positron Collider has played its part. If you're wondering, a positron is an anti-electron. And indirect measurements, theoretical physicists have played their part. Tevatron has. And now that the LHC has been up and running for a while, and soon enough, they will be running at full power, 7 tera electron volts. Then I'm sure that the Higgs will come out within a couple of years from now, especially when they get it up to the full power in the LHC. And that is the end of my script, so that's the end of the Higgs boson. So if you want to start a big debate in the comments over whether the Higgs exists or not, and you happen to be a particle physicist, or you happen to be just a regular old person, and you want to put your 2 cents into it, go ahead. You know, I really wouldn't mind something like that. I wouldn't mind you calling me an idiot if something I've said is wrong. Go ahead, do that. I would love to fix it by putting one of those notes in the video like I have at the beginning saying this is episode whatever, go watch my other episodes. I wouldn't mind putting something over it that says this is incorrect, so that's where we stand with the Higgs right now. And if you want to really impress the scientists and you see them, don't call the Higgs the God particle, call it the champagne. I think it's somewhere in this Wikipedia article here. Let me know if you want to make the mouse bigger, by the way. That's something that's been suggested, but not really. Okay, here. They call it the champagne bottle boson by a jury of physicists because it's not really the God particle because it overstates its importance, like it says here. It would still leave unanswered questions about gravity and the origin of the universe and blah, blah, blah. Lots of crazy stuff that is, I don't know, most likely not discovered in our lifetimes, although I certainly hope so. That would be really cool. But called the champagne bottle boson, and that will be pretty impressive to them. So, thanks for watching the video, and hope you like the script setup. I might keep doing it because if you've ever been in front of a camera and you try to talk about something super advanced, which isn't your day job like me, I don't have a job, too young, but then you're most likely, you know, like half your intelligence goes away, as has been said, once you turn on the camera, which is true for me also. So I figure if I write the script before I've turned on the camera, or in this case the microphone, and the Hypercam 2, as you can see way up here in the corner, then I figure I can still read fine, and I still have my personality, which I want to keep in my videos, which is why I'm not following the script religiously. In fact, I've exited the script quite a while ago. That still stays, so as long as I can do that, I figure I write a script, I can get all the facts right. I hope so, at least. So, that's the end of the video. So, thanks. Bye.